Hello, everyone, and welcome. Today, we're going to discuss how a biotech firm streamlined data protection on Amazon Web Services with AWS and Rubrik. My name is Mike Lewis. I'm the Partner Solution Architect here with Amazon Web Services, and I'll be your moderator today. We also have Ken Hoy, Technical Marketing Engineer with Rubrik, and Mark House, Sales Engineer with Rubrik. Today's agenda, we'll keep it simple. I'll begin with a quick overview of backup and recovery on AWS. Then we'll hand it over to Kenneth for a discussion of Rubrik Cloud Data Management. And then finally, we'll hear from Mark as he discusses his case study with Fuji, Rubio, and their journey to modernizing backup and recovery with AWS and Rubrik. So what are our learning objectives? Primarily, we want to learn how to simplify data backup and recovery for both cloud native and hybrid cloud environments. So AWS provides a lot of services for cloud data backup. There's a vast array of options for on-premise. But today we're going to talk about how Rubrik can help you build hybrid use cases and use the same set of software to back up cloud solutions as well as on-premise solutions and bring it all under the same pane of glass. We also want to learn how to quickly access and mobilize our apps for data, applications and data from data centers to AWS securely. So we want to talk about how to move those applications and data quickly and easily in a secure fashion to AWS. We also want to learn how to control both our on-premise and our cloud apps with a rich suite of API services. So again, bringing on-premise as well as cloud applications under the same APIs. And then finally, we want to learn how to instantiate workloads on AWS as a cost-effective disaster recovery solution or for test and development. And just as a quick aside, as I was working with Rubrik on the learning objectives for today's webinar, in my own career, I spent about 10 years doing disaster recovery and recovery testing. And we often were only contemplating workloads for production for disaster recovery, which was typically based on cost decisions. So it was very expensive to bring applications into our disaster recovery portfolio, with the consequence that when we actually performed recovery, we were only recovering production. However, when we did recovery, it was very typical to immediately need to change that production application to accommodate either the reality of the new recovery site or just the nature of the disaster. And so we were contemplating changing production without access to effective test and dev. When we're contemplating AWS and Rubrik, we can really bring a cost-effective solution into play. And that can allow us to actually contemplate increasing the scope of the applications that we're going to recover at the cold site. And so even to the point where we consider bringing dev and test along with us. So a quick overview of background recovery on AWS. So the first thing I like to talk about when talking about AWS for backup and recovery, and especially disaster recovery, is the global infrastructure AWS provides. So what we're looking at here is a list of AWS regions across the globe, 16 regions available today, with 6 more announced and coming online soon. So what's a region? A region is a set of data center assets arranged into availability zones. And each availability zones in that region is one or more data centers. Working backwards, an availability zone is one or more data centers. A region is 2 or more availability zones. And of course, we have 16 regions available to deploy your data assets. The second thing I'd like to talk about is key AWS certifications and assurance programs that AWS is aligned with and works with diligently to help customers build compliant applications in AWS. So security is the most important thing that we can do at AWS. It's the first thing we think about when we build new services or launch new regions. It's the first thing we think about when we deploy new features for our services. And we do this because our customers tell us they can't have success unless they can comply with the regulatory bodies that they work with in industry. So AWS works carefully with both industry bodies like HIPAA or PCI DSS for payment processing, as well as governmental bodies, both in North America and across the globe. So this is just a quick preview of the available certifications that AWS works with. For a full list, please go to aws.amazon.com/compliance. As we've seen, AWS has global scope with regions across the globe. We work with a variety of regulatory bodies, both in industry and in government. And so now it's time to talk about the platform. So these are the services for storage that AWS provides. And in 2018, AWS provides a comprehensive, mature storage platform for your workloads. We can look at this across a couple dimensions. If we look at it horizontally, we see that AWS provides services for file. So Amazon EFS provides a file level access. It's a file service available with NFS 4.1. And this is a regional service. So I talked about regions. I talked about availability zones. Amazon EFS and other services will automatically distribute data assets across that region and across the data centers within the region, or the availability zones within the region, to create a highly durable artifact. AWS also provides block storage, which we'll talk about extensively as we discuss the rubric use case. Amazon EBS is block storage for your virtual machine. It's network attached. It's decoupled from the lifecycle of the virtual machine. That means that we can detach these volumes. We can snapshot these volumes. We can copy those snapshots into other availability zones or other regions to enable backup and recovery use cases. We can change the volume sizes. We can change the volume types, and we can do that online. Amazon EBS provides a variety of different types of volumes for different performance and cost objectives. Amazon EC2 Instant Store is block storage that is associated with the lifecycle of the virtual machine. That means it's available when the virtual machine is on, and it's not available when the virtual machine is turned off or terminated. But we can provide even more capabilities with i3 NVMe-based storage, providing millions of IOPS, and other options for magnetic media for very large streaming workflows or data warehousing applications. Then moving finally to the right, we get to my favorite service for backup and recovery, disaster recovery, Amazon S3. Amazon S3 was launched in 2007, substantially the same API. This is really important for archival and backup and recovery use cases. When I deployed an object into Amazon S3 in 2007, I'm going to operate exactly the same set of APIs to investigate that object in 2018. So it provides a nice consistency for me that I can organize my workflows around. I can build applications around it. It's a scalable service. That means that when I create an object, I'm going to define a name for that object, and I'm going to put data into that object, anywhere from 0 bytes all the way up to 5 terabytes in a single object. And I don't have a limit to the number of objects I can store. So that's also really important for backup and recovery. I also only pay for what I use. So I'm not provisioning space in Amazon S3. I'm just going to deploy data into it and pay for exactly what I use. Amazon S3 is also a durable service. So with 11 nines of durability, and it achieves that durability by using those availability zones within the regions we were talking about automatically. So when I write an object to Amazon S3, I'm going to choose a region, make a bucket in that region, and then Amazon S3 will automatically distribute the data across the availability zones within that region on my behalf. Importantly, and this is true of all services, Amazon will never move that data outside that region unless you tell us to. So when you choose a physical region to deploy data into, you can be assured that that data will stay in that region, and this is really important for compliance. Many customers who are working with a regulatory body need to be assured that the data, customer data that they're processing, confidential business data, remains physically within a particular region for data sovereignty purposes. And with AWS, you can be assured that that'll be the case. So, and then finally, Amazon Glacier, also key value. But Amazon Glacier is designed for archival use cases where we don't need immediate access to data. None of these services would be particularly interesting if we didn't have a way to access the data over the network. AWS also provides a comprehensive secure store platform for moving data. AWS Direct Connect is a peering connection. So this is a dedicated transit that you can set up between your data center or your data centers or your network and AWS. AWS Snowball is a really interesting service. It's a physical device that we can ship to your location. So you log into the console, click a few buttons. AWS will send you a Snowball. You plug that into your network, load it up with data, and send it back to us. So AWS will handle the shipping both ways. We'll handle scheduling the shipping. Amazon has a lot of muscle memory and some good institutional knowledge about shipping things to customer sites. Take advantage of that. So when we move the Snowball back to AWS, and we'll upload that data into Amazon S3. You can also reverse the streams. You can set up a job to copy data from S3 into Snowball and send it anywhere you like. AWS maintains a variety of ISV connectors. Amazon Kinesis Firehose is to stream events in Amazon S3. Amazon S3 transfer acceleration is available, so I didn't want to clutter up the global slide. But in addition to the regions, there are more than 100 access points to the Amazon network deployed around the world. We can use those access points to accelerate download and accelerate upload into Amazon S3. So the storage platform is integrated, and we'll talk about that a little bit more in a second. So Amazon storage services work well together. Amazon EBS snapshots actually are deployed to Amazon S3. So Amazon EBS snapshots get that 11 nines of durability and regional availability by integration with Amazon S3. Amazon S3 is also integrated with adjacent services for key values. So as an example, we can upload data to Amazon S3. Active data may live in Amazon S3 standard. We can lifecycle that out to infrequent access, and then finally move that over to Amazon Glacier when that data is going to be accessed less frequently, or that we can accommodate a 4 to 6 hour job time for recovery. We can either do this by operating the APIs, or we can do this by setting up lifecycle policies with Amazon S3. Again, the important point is we can lifecycle this data all the way to Amazon Glacier, but we can still operate the Amazon S3 API to check that data's health through its lifecycle, which is important for archive. And they can also use that Amazon S3 to recover the data. So just really quickly, what are some benefits for AWS for backup and recovery? Just in summary, the AWS Storage Foundation is integrated, both integrated with adjacent storage services, integrated with each other, and then integrated with other AWS services up and down the stack. So Amazon RDS for relational database services is integrated with Amazon S3 with snapshots flowing to S3 automatically. Amazon S3 is secure, so we can, of course, encrypt the data at rest automatically on Amazon S3 and Amazon EBS. We can encrypt the data in flight. We have a comprehensive set of APIs that control access, and just as important, we have a comprehensive audit logs to understand exactly who is accessing our data through its entire life cycle. It's easy to maintain. Of course, AWS will handle the hardware maintenance for archival use cases. We might have on-premise several generations of equipment that we need to maintain over periods spanning decades. In AWS, we're going to operate that simple S3 API and leave the hardware management to Amazon. It's scalable. We can scale in and out. So scale up with your needs, but importantly, scale in with your needs. Really important for disaster recovery and backup. And then low cost. So all of these together allow me to build a really low cost, cost-efficient infrastructure where I'm paying only for what I use. Again, this enables me to contemplate kind of new use cases for disaster recovery. Instead of picking just the highest value production applications to move, I may actually contemplate introducing other production applications that would be useful for disaster recovery, or maybe do my whole environment, bring test, dev, and test along with me so that when I perform a disaster recovery, I can actually modify my production application without changing the production app without test. And so finally, what are the benefits of using an APN partner? So an Amazon partner network partner to help customers achieve their objectives on the AWS platform. So I talked about integrated platforms. I talked about global availability of the service. I talked about compliance. How does Rubrik help us? They help us by assembling all these tools in an easy way that's really aligned with our use case. So Amazon provides a lot of the muscle. Rubrik provides a lot of the intelligence and alignment with your use cases to help you move the data quickly and efficiently to AWS, to manage snapshots, basically to build easy configuration and tight alignment with exactly what you're doing on the platform. So they can bring features like incremental and block level backup, kind of intelligent use of that transit we talked about, and really build cost-effective solutions for rapid recovery. And with that, I'm going to hand it over to Ken for a discussion of Rubrik Cloud Data Management.
Thank you, Mike. My name is Ken Hui. I'm a technical marketing engineer at Rubrik. I'm happy to have this opportunity to talk with you about our next generation cloud data management platform and how we're helping customers with their cloud journey to AWS. So let's begin by taking a look at traditional backup solutions that you see in the market today. We can see that these traditional solutions really were originally designed only to protect physical servers. So over time, as new demands grew around needing to back up virtualized environments, backing up cloud, and also backing up explosive data growth, these new capabilities had to be bolted on to these traditional solutions, things such as replication, tape, dedupe, backup proxies, and the like, in order to meet these new and growing demands beyond physical. But having all these new capabilities also came with price, a lot of added complexities, as you can see here in the slide. That's a lot of moving parts that needs to be customized, they need to be integrated together, and very often that meant very long service engagement from the backup vendor supplied to the customer in order to be able to integrate all the pieces and then to be able to support them through the life cycle of that solution. So Rubrik actually decided to take a completely new approach to this by designing our solutions from the ground up to take a new approach in protecting not only physical servers like Windows and Linux, but virtualized environments like VMware and Hyper-V, and also cloud workloads like you find in AWS, and finally very large data sets like SQL Server and Oracle databases. I mean, there were some very basic design principles that we followed and applied to our solution. First and foremost is that we decided to converge the platform, as you can see here. All these piece parts that you had in traditional solutions to give you the capabilities that are needed for a modern data center, we've been able to converge onto a single platform that runs as a software that can be implemented on a standard x86 hardware as virtualized instances in your data center or as cloud instances running on AWS. And this converged platform was built from the ground up to be scale out so that as your environment grows, you can add additional Rubrik instances and they'll scale to meet your needs, just as AWS scales to meet your needs. And along with scaling from a hardware and bucket file system perspective, we also have automated policies that can adapt to your changing environment and then intelligently adjust to changes. So, for example, as you add more databases or as you add more virtual machines and servers to backup, you don't actually have to create and modify new backup jobs and move things around. We will actually do that for you to ensure that no matter how much your data grows, it is always protected. And finally, we wanted to help customers leverage the power of the public cloud. And so we integrated Rubrik with cloud platforms such as AWS to help customers in their to get more of their cloud investment. So I want to look at specifically at some capabilities that Rubrik has around cloud that enable customer use cases in AWS. The first is Cloud Out, which is our ability to retain data and archive data in the cloud using S3 and Glacier. Second is Cloud On, which is our ability to instantiate your on-premises workloads and run them in AWS for the purpose, as Mike mentioned, of DR for test dev and also in some scenarios for migration. And the third is our Cloud Cluster, which is a software virtual instance of Rubrik running in AWS using EC2 instances and EBS that allows us to back up your cloud native workloads running in AWS. And for today's webinar on the customer use case, we want to focus very specifically on the first two use cases and address them in more detail. So first thing we want to look at is Cloud Out, which again is our solution to enable customers to back up their on-prem environment. As you can see here that there are many platforms that we back up, and then send that data to S3 for retention. And there are many reasons our customers are doing that today. The one very prominent one is as a replacement for their tape infrastructure. As many of you know, backing up to tape and then storing it off-site is a process that's very arduous and prone to error and complexity. And so by leveraging S3 as a replacement for tape, many of our customers have found it to be a more cost-effective, much more reliable, 11 nines of durability, and more highly available solution than the old way of using tape. In addition, we have customers that also, once they have their data sent to S3, they're now able to launch environments where they can access that data for things such as analytics, and also for things like test dev, and as Mike mentioned, for DR. So a very typical use case for our customers is to retain, say, the last 30 days, most recent 30 days of backups on site on a Rubrik appliance, and then storing anything older than that in S3 for retention for restored in the future. And other use cases is customers, again, sending their most recent backup immediately to S3, where they can leverage various AWS services to perform tasks like analytics and for testing. So along with support for S3, we also support archiving data to Amazon Glacier for long-term retention. And this, as mentioned, this is typically for data that customers aren't going to access very frequently. Perhaps maybe it's data that's older than 90 days, and it will only be accessed in very specific cases, and where a retrieval delay is acceptable. And so we allow customers to store the data in Glacier, and then we also integrated fully with Glacier's Vault Lock for compliance control, so that customer can apply a lock to that data, and they will have an audit trail to ensure that this data is retained according to compliance regulations. So to provide the best experience possible for customers, Rubrik stores files in S3 very intelligently. So for example, instead of having to send a full backup of your data to S3 every single time, whether it's if you're taking your backups every few hours or every day, we'll send some full backups, but in between, we'll only send the incremental changes to S3 to store, and we keep track of those change blocks so that you're able to restore to any point in time relative to your backups. So this minimizes your storage costs in S3. So from a restore perspective, when you need to restore a virtual machine, whether it's VMware or Hyper-V, we don't always require you to send all the full virtual machine back from S3 to your on-prem environment. We only send the change blocks that are stored in S3, and then once it's on-premise, we'll consolidate that with the data we have on-site in order to recover your VM while minimizing bandwidth and transfer costs. And that same thing holds true when it comes to a file level recovery. Instead of having to restore the full server or file system, we can restore just the files, the specific file that you need and the blocks underneath them, again, to minimize bandwidth and transfer costs. And finally, we actually store the metadata for every object with the object as they are being sent to S3, so that if in the event that your on-premises Rubrik appliance is not available for some reason, we have the metadata in S3 and can do a very rapid recovery of that data. And as Mike mentioned, security is job one at AWS, and that is the same for Rubrik. So we know data security is always going to be a concern, especially in today's modern enterprise. And so Rubrik is designed to provide end-to-end security. So for data, for example, data is encrypted in transit using TLS during backups and restores between your production environment and the Rubrik appliance. And then once that data is landed in Rubrik, we encrypt it at rest using 256-bit encryption based on the advanced encryption standard. And then from a cloud out perspective, every communication between Rubrik and S3 in terms of sending data and communication is encrypted, again, using TLS. And even before we put data on the wire to be transferred over, it is encrypted using client-side envelope encryption. That means that the data is first encrypted using an AES 256 data encryption key. We then further encrypt that key using an RSA 2048 key that is supplied by the customer or through the Amazon Key Management Service. And once we encrypt that data key, we store that with the encrypted data and then send it off to S3 to facilitate recovery, backup and recovery. And so by doing so, we ensure that you're always protected, your data is always protected end to end. So taking a look at the second use case, Cloud On, which is our ability to instantiate workloads in the cloud. So what Rubrik Cloud On allows customers to do is take the backup of the on-premises data that they have sent to S3, and we can actually take that backup image and instantiate it using EC2 and EBS as a replica of their on-premises environment running in AWS. And a typical scenario for doing that, typical scenarios include replicating your on-prem production environment so that you can run tests and you can do application development on that environment. Some customers use this as a tool to actually migrate their on-premises workload to AWS. And as mentioned earlier, you can actually use the replica as a disaster recovery environment. And all this is done in order to provide customers more agility, because now they're able to leverage the on-demand elasticity of AWS. And they can do that also to eliminate kind of idle infrastructure. You know, in the old days, in order to have a fully functioning DR environment, you would essentially maintain a second data center that would essentially suck up costs while it's not being used. In this case, by leveraging Rubrik with AWS, you can use the cloud as your DR environment, but only pay for what you use in a DR scenario or a DR test scenario. So here you can see an example of how Rubrik could be leveraged in order to do DR test dev. In this case, we're using Rubrik to seed data into Amazon S3. And then from there, we can actually make calls out to the Amazon import-export service, which will convert your virtual machine images, such as your VMware VMDKs, into Amazon machine images. And then we can use those images to launch EC2 instances that would represent a replica of your on-premise environment, but now running in AWS. So as you can see, Rubrik's cloud data management platform is designed to help organizations manage their data, no matter where it sits, whether it's on-premises or in the cloud. And it does is using a common interface. So you're using the same dashboard and tools to manage your on-prem backup as you are managing the data in AWS. We also provide a set of very robust REST APIs that enables you to integrate any number of configuration management tools and orchestration tools so you can automate your workflow. And then the software can run anywhere, whether it's a hardware appliance that's sitting in your data center as a virtual instance in an edge location, or sitting as a cloud instance in AWS backing up your cloud native workloads. So thank you. And at this time, I'm going to turn it over to Mark House, who will walk you through a customer use case of how customers using AWS and Rubrik to further their cloud journey. Thank you.
Okay, thanks for the intro, Ken. Again, my name is Mark Hawes. I'm a systems engineer with Rubrik for the past 2 years. You know, we're going to talk about some things that Fuji, Rubio, Diagnostics have. They're actually a customer in the Philadelphia area. I've had the pleasure of working with them for over a year. They actually have labs in order to measure the presence or the severity of diseases in blood and body tissue. So quite literally, they are helping to save lives every day. And they, you know, besides all the lab work, Fuji Rubio has to maintain data records. They have custom applications along with their normal business processes. And data management is very critical to keep the lights on and stay in business for them. IT solutions must be easy to use. They must be reliable and allow Fuji Rubio to grow their technology in the future. So it just can't be a very point solution. Fuji Rubio invited Rubrik to design a next generation state-of-the-art data protection solution a little bit over a year ago now. Some of the backup challenges that we discussed with their current legacy environment included management and monitoring time, expense of full replication, and they're also looking to utilize cloud and nearline NAS. So one specific challenge they faced was that their legacy infrastructure was reaching end of life, and the hardware and software required constant management. Their legacy architecture was designed for physical and virtual, but now Fuji Rubio is 100% virtual. So this was, you know, key that they looked at for their future environments. Fuji Rubio keeps retention of data for 7 to 10 years, This was becoming difficult and very costly with tape management. They needed tools with modern orchestration and automation to streamline some of the operations that they were using. And most importantly, the ability to recover virtual machines or search for files in their archive was very limited and time-consuming in the past. So as project goals, Fuji Rubio would, they wanted to update their 5-year-old design to a new purpose-built technology, and they also wanted to add sufficient capacity for growth in new systems. So it couldn't just, simply handle what they had. They needed to be able to grow easily. They also had a colo for replication. This was becoming very costly. So they would like to utilize their nearline NAS and cloud instead of their colo. A couple other goals were reducing their recover point and time objectives. They need to make sure that they can get their data back in a timely manner. And again, they wanted to use automation and scripting to customize specific reports that they have, use month-end reporting very efficiently. So moving that to additional servers that they had in the environment. They want to automate recovery of virtual machines. And in general, they want to make sure that they can eliminate any unnecessary costs in their data center. So Rubrik, along with AWS, has removed their legacy infrastructure, including their backup servers, software, tape, and we were able to reduce the footprint and create operational simplicity compared to their legacy solution. Rubrik definitely achieved better than 77% data reduction with deduplication and compression. One key feature of Rubrik was to provide global indexing and search capabilities for granular file level recoveries from Rubrik and AWS. Fuji Rubio is also able to instantly recover and perform live mounts or make copies, full VM copies of their environment using Rubrik resources for near zero data access, including granular exchange recovery in minutes. And they were able to repurpose their NAS in the DR site for near-term recoveries while using AWS for their long-term retention and recovery. So Fuji Rubio set Rubrik up themselves in about 30 minutes and was able to back up, search, and recover files and VMs in the same day. There was no formal training, long SOWs or PS engagements. This was something that, through our GUI interface was very intuitive, just really enabled them to get up and running in a very quick amount of time. Their integration with automation tools and custom scripting streamline all the reporting that they require on a regular basis, especially their month-end, and all the recovery processes as they went through different test scenarios, DR testing, and also full virtual machine level recoveries. So by implementing Rubrik and AWS for backup, disaster recovery, test dev, and archival, Fuji Rubio saw a 75% reduction in TCO from their legacy infrastructure. This was a result of smaller footprint, less management, automation tasks, and really being able to reduce their data center and their daily activities based on backups. So Fuji Rubio loves Rubrik because of the AWS integration that performed seamlessly. They get deduplication, efficiency, and performance in the cloud now. They use AWS for instant archive of mission-critical data, long-term archival, and to expand the on-site storage capacity. So they, as a pressure release, if they start adding too much data or too many new applications and grow the local environment, they can just reduce the amount of time that they keep the data local and move that right out to S3. So really enables them to be able to monitor the data flow that they have, and definitely eliminate the risk of overextending the environments. They've also been able to eliminate the tape complexity and the cost and management by using AWS. So no tape in the environment, strictly on-prem Rubrik and AWS for that long-term retention. So now Fuji Rubio has the ability to recover files and applications almost instantly, instead of waiting hours and days and weeks as they previously did. So very reliable on the recovery and being able to respond to urgent needs that their infrastructure needs. And definitely been able to test quickly with live mounts. So this is again making use of Rubrik resources in order to bring on a virtual machine as a test environment. They also use live mounts for month-end processing. So they're actually moving that process off to another host, so there's no issues with production servers. And they also are able to get applications, new applications, into production a lot faster. So just much more streamlined in the way that they're able to test and figure out new code and new applications and get them online a lot quicker to enhance their business. In the future, they're looking to add more functionality through Amazon. They are looking to instantiate, so truly remove their DR center that they have and use AWS as that DR center. So looking forward to working with them more on that. They're going through some test cycles at this point, but really being able to build on what they have today. So not just on the Rubrik side, where they can add a lot more functionality, a lot more data aspects to it locally on-prem, but being able to utilize Amazon through S3, through EC2 in the future, really getting the best value not only now, but moving into the future. So with that, I thank you for your time today. If there's any questions, I know we'll be opening up the phones and chat. So I'd be glad to answer any questions that you might have.
Well, thanks for that, Mark. That was some great details. I get a little excited about the disaster recovery use cases. I actually entered my career into a major university system with the title of tape librarian in the 90s. And nice. It's amazing to see the capabilities that we have today, that really to solve a lot of those problems with the physical manipulation of tape, maintaining chain of custody through tapes life cycles. I was working with tapes in the 90s that were at that point 25 years old and expected to maintain like a recovery capability for that. So it's amazing to think about, pushing that into Rubrik appliances and having that data online, migrating that, life cycling that data out to S3 or Glacier for long-term storage, but kind of maintaining that kind of instant availability for quick testing. It's no longer a mystery if we call the offsite provider and wait hours, for the tapes to hopefully arrive, and hopefully they're intact and recoverable. In some cases, those tapes aren't there, and then we have to try to decide what was on those tapes. So this full life cycle encryption, that we're completely handling that story now and solving a lot of these problems. So I just get a little excited. I think it's even more impressive though to think about moving dev test workloads, automatic migration of machine images up to AWS, the Rubrik capabilities for dedupe. So it's really just an additive story with S3 and Glacier and EBS, across the world in AWS regions, but it's really enabled by Rubrik software in a really intelligent and cost-effective way. That's the anyway. I get a little excited. So let's take a few questions here from beyond my experience, the folks on the webinar today have a few questions. One that comes up a lot, and I touched on it a bit, but when we start to think about using AWS for backup and recovery or to migrate workloads, we need to think about the network pretty extensively. So we have significant data center assets. We've got significant data either on-prem or on tapes. And so what sorts of network considerations did Fuji Rubio consider when they were thinking about using Amazon to locate their backups and to enable these data flows?
Sure. So number one is security. So Ken reviewed a couple different things there as far as encrypting data and how we use AES 256 to make sure that things are secure. But after that, it was really based off of bandwidth. So they want to make sure that data gets moved extremely quick. So bandwidth is definitely based on the data amounts that need to get moved. But with Rubrik, we use that first full incremental forever methodology. So along with dedupe and compression, so that daily traffic is truly only the changes that get moved from the on-prem Rubrik out to S3. And Fuji Rubio did do some testing. They moved a couple machines over first, just to make sure they understood what the bandwidth requirements were. But they really found that they could move it over quickly because it truly doesn't use a lot of bandwidth. And even moving forward day to day, again, it's just the changes that are being replicated out to S3. So bandwidth was just not really a concern at the end of the day.
Awesome, and I think I saw from your presentation that the general strategy is to emplace those backups locally for rapid recovery, and then we can flow those backups out to S3 for recovery in the cloud or for maybe a recovery in a different region for DR. Is that right?
That's correct. Yeah. So
okay.
And then and in the future they are looking at doing the instantiation. So that's really a good savings for them. Not to have a formal well, theirs is a colo site that they pay for. So to be able to use the resources right out of Amazon, that the data is already there, so it makes it real quick to enable that and utilize the cloud on capabilities to do the instantiation.
Okay, awesome. Getting a few questions about the services that Rubrik supports, and maybe Ken, you can pitch in here. So AWS has a rich set of services for storage. We talked about EBS for network attached block storage. We talked about S3 and Glacier. Kind of hinted a little bit about the existence of S3 and frequent access. Ken, I think you mentioned Glacier features like Vault Lock. So AWS is releasing new services and also adding features onto those services all the time. So the question is, what sorts of services does Rubrik support, and specifically, do you support all of the different tiers of S3 storage? So that would be S3 standard and S3 and frequent access at this point.
Thanks, Mark. Mike. Yeah, so we definitely support both the S3 standard as well as the S3 infinitely access. So we work with customers to kind of figure out which tier they should send data to right from the get-go, or we kind of help them figure out what this storage tier lifecycle management policy should be. And for us, it's transparent. We can access the data no matter where it sits in S3. In terms of the other services and storage platforms, we're constantly adding new integrations all the time. So in a very soon coming release, we'll actually be able to support EBS snapshots, for example, and be able to manage them from a single interface using the same API that they use now to manage their on-premises and backups and snapshots.
Awesome. Yeah, that's where I really get excited about this story as well. So we could talk for a long time about the various services of the AWS platform, but Rubrik was really kind of assembling the critical services and critical features into kind of a sensible workflow for for moving dev tests, for moving data and applications into the cloud, and enabling things like disaster recovery cost effectively. But without you as a customer necessarily, needing to really dive in on how these services integrate and interoperate, Rubrik can handle that for you. Another question for Mark. So we talked about kind of how fast Fuji Rubio was able to get up and going with Rubrik. It seems like they onboarded themselves and took maybe 30 minutes to figure it out. That's pretty impressive. It would probably take longer, safe to say, if they were attempting to script S3 directly. I don't mind sharing with you. So how long did that end to end I guess project what were the project timelines? Did it take a long time to upload the data? It seems like they familiarize themselves with the platform pretty quickly, but obviously the project timelines could extend. I think on premise we often look at months at least, maybe years to introduce a new backup product. So what were the timelines for Fuji Rubio?
Yeah, no, definitely not months and years. So they, as I stated before, it took minutes to actually get Rubrik installed and configured and starting to do backups. As far as configuring the AWS, they procured that S3 bucket directly through AWS, and really from the Rubrik GUI, it was a matter of we just put in the bucket name and some keys to identify it, and then set up a retention policy. So again, only minutes. This was all accomplished within the first day that we went on site to implement. And then as they did a couple tests throughout the week and then started to migrate their full environment. But basically, they were able to migrate most of their environment over a long weekend. Total project time may have been 2 to 3 weeks till they got very comfortable with everything, and the full production environment was moved over. So saved a lot of time.
That's amazing. That's one of the things as I came to AWS that I kind of needed to recalibrate. I had been used to, as a customer, looking at POC timelines that were, months or quarters at least, and working with POCs on AWS platform. It's, we schedule out a few months of meetings, but after the first week, we're already having success and maybe looking at each other and trying to decide if we need to get back to work because the project and the POC might actually be finished by that time. So the timelines are really compressed. And another factor there is that it's de-risked. We can be really agile with AWS because we can spin up the resources, we can investigate these POCs, we can decide if it's working for us, and if it's not, we can hand that infrastructure right back to AWS. So we don't need to make a hardware commitment. We don't need to look around our data center assets and try to find some empty space or some white space to do a new project. We can really just spin up compute network and storage really quickly, investigate our data, investigate workflows. If it's working, fantastic. We can productionalize it. As Mark indicated, we might have to make that decision faster than we thought we would because we'll probably have some early success. And if it's not, we just we hand it right back to AWS. As we extend that model into other areas of the business, AWS provides the foundation to investigate. When we put data in S3, we can make it available for backup and recovery, but we can also make it available for analytics. That the data isn't sequestered on a tape and offsite; it's online and available for access. A couple other questions here. So I think we mentioned it kind of quickly in the slide, and it was certainly something that I like to call out, and that Rubrik appliances live on-premise, but they can also live in the cloud. So I just wanted to make sure I had that right, Ken. So we can stand up a Rubrik appliance both on-premise and a virtual infrastructure, as well as in the AWS cloud. And so the question from an attendee here is, what are the requirements to run Rubrik in AWS, both for EC2 and the storage?
Yeah, great question. So one of the benefits of one of the earliest slides of having everything be a single converged software platform is essentially the software can run anywhere, right? Because we're not really dependent on the underlying hardware. And so we can run, on standard 86 hardware, but we can also run on virtual machines or cloud instances. So With the cloud cluster, basically, we're kind of replicate a highly available Rubrik appliance. So it's essentially in AWS, it'd be 4 EC2 instances that size properly with some SSD storage using obviously EBS. And all that's detailed in our user guide. And basically, we supply an Amazon machine image that a customer can then use to launch what we call a Rubrik cloud cluster.
Right. Okay. So you're going to use, so the EBS volume type would be probably GP2, which is an SSD-backed general purpose volume, or do you use provisioned IOPS EBS storage?
We use, I believe, the GP2. We're basically using that, leveraging the SSD for just dedupe and other processing. Right.
Got it. And then if I understand right, the actual blocks are stored in S3 as well as the file metadata. Is that right? So we can kind of stand up one of these virtual appliances and point it at the data in S3 and kind of build out our environment from there. Is that correct?
Yeah, so the metadata is stored, as you said, with the object, and mainly that's for DR purposes. So if an appliance goes off, if for some reason your on-prem data center is unavailable, we could essentially stand up another appliance or even a cloud cluster, and it will just read that data, right, the metadata, and be able to reconstruct your backup.
Okay, great. Another question about file recovery. So I know this is, as a backup administrator for an HMO for 8 years, this occurred with some regularity. As a user would ask for a file that was deleted some years ago. So this would be a file level recovery request. In Rubrik, do we support file level recovery, or how would we go about recovering a single file from a file system from a virtual server from years ago?
Yeah, so great. So we actually back up either at a VM level, or server level, or a file system level. But in all cases, we basically kind of track the metadata for those files. So we actually know where every file is and the version of that file, whether it's sitting on premise in Rubrik or in S3. And basically, we also enable the search capability that's similar to what you would find actually in Google search. And a customer can say, search for a file, and we'll basically list every backed up version of that file that's sitting either on-prem in or in S3. And the user just chooses that version of that file, and we'll recover it. And it's transparent to the customer where that file is sitting, on premises or sitting somewhere in S3.
Okay, fantastic. I think we have time for one more question. Maybe not enough time. This is a relatively complex question, probably with a lot of moving pieces. But if I am running a backup solution on premise that's managing a lot of tape offsite or in a tape robot, is there a best path, a white paper? Do we have best practices for kind of getting all that tape kind of under Rubrik management?
Yeah, so that's probably something would take longer than a minute to answer. We do have integration through a product called QStar that actually can essentially use tape as an archive target. So a customer could use Rubrik to actually send things off to tape. And then over time, we would probably need to work with the customer to figure out what the best way is to transition over from using tape to using S3. But that's a longer discussion that someone like Mark House would sit down with customer and map out.
Right, and that's kind of leading into, the details of your system may be complex and your requirements may be complex. So encourage you to reach out to Rubrik, for consultation on some of those more complex use cases like importing legacy backups. What's the best way to get that to AWS? What sorts of technologies should we leverage to seed those initial backups and get that migration moving? But I think we could definitely help you out. So invite you to reach out to Rubrik to answer that. So at this point, we need to close the webinar. Thanks everyone for attending. As we're looking at here, lots of great next steps. You can get more technical information on rubrik.com/resources or rubrik.com/blog. There's a great ebook describing this scenario with Fuji Rubio. And then finally, of course, you can always try AWS for free, aws.amazon.com/free. So I think I went a minute over. Thank you for your time today. Thanks for attending.